Okay, this lesson is on solving rational equations. And the first thing we need, we look at the denominators. We ask ourselves, what is the least common multiple? Which is the same thing as the least common denominator. And as we look at this, now remember, these are numbers, or these are factors that all three of the denominators will go into evenly. We're not looking for the least common factor, which would be 2a. See, 2a would divide into 6a, 2a squared, and 6a squared. But we're not looking for that. When I say the word least common multiple, we're looking for the smallest term that all three of our denominators will divide into evenly. Now the reason we're doing that is so we can take that least common multiple, multiply each fraction on both sides of an equation, and rid ourselves or cancel or clear the equation of all the denominators. Then we can solve it. So that's our goal. Our goal is to clear the fractions, clear the denominators, but do it with the algebra technique that you learned in Algebra 1, where you can do anything you want, any operation you want on both sides of an equation, as long as you do it to everything on both sides. So if we look at the 6 and the 2 and the 6, the least common multiple for that would be 6, a squared for the variable. So now we're going to take each fraction, 1 over 6a first. We're going to multiply it by 6a squared over 1. Plus, now we're going to multiply the next fraction, 1 over 2a squared times 6a squared over 1. And that equals 1 over 6a squared times 6a squared over 1. You could also do this if you want to make it a little bit more of a separation, so you can see that we've done the same thing here to every fraction in the original equation. Now we can simplify like we did in the first part of this chapter. We learned how to simplify rational expressions. Whatever makes a 1. So we have a 6 over 6. We can cancel an a with the a squared and leave me an a. So I have 1 times a, which is a. And we cleared that denominator. And we have a plus. A squareds cancel here, making a 1. When we say cancel, we mean they're actually making a 1, and the reason we can cancel is because it's not a 0, it's a 1 times anything concept. You have to think about the identity theorem about this, right? So the next thing is 2 goes into 6 3 times, so we put a 3 up here. These are connected by multiplication. So now we have 1 times 3, which is 3. Cleared that fraction. Now the next one is nice because everything cancels with the top and bottom, leaving us 1. Now we have a simple algebra equation, which means we'll subtract 3 from both sides and come up with our answer. Now one thing we have to start doing on this is checking for what's called extraneous solutions. The denominator cannot be 0, so we have to remember to look at our denominators and check and see if the solutions we have, if they make any of the denominators 0, which is undefined, because you cannot divide by 0. We don't have an answer for that in the real number system, so you have to make sure that you check for that, and you have to exclude any of those answers that make the denominator 0. But we don't have that in this case. Negative 2 is our answer. All right, now I'd like you to try number 2 on your own. So I'm going to give you a little bit of time to try that and see if it works for you. So you try that and see if it works, and we'll come back and work it here in a little bit. Actually, what you need to do is pause your video. Pause your video, work the problem, and then check it with my work. I'm going to go ahead and work it for you. All right, here we go. Looks like our least common multiple here is going to be 5k squared. So again, we have 1 over k squared times 5k squared over 1. You want to put a parentheses like this, that's good. Plus, this time we have a binomial in the numerator. There we go. Times 5k squared over 1 equals 1 over k times 5k squared over 1. Again, we're doing the same thing to everything on both sides of the equation. I like to say it's algebraically legal. That's not a math term, but I think you understand what I mean. Look at the first fractions. K squared makes a 1, leaves me a 5. Plus, oh my goodness, this is nice here. These both cancel, making a 1, leaving me 6k minus 3 equals, but here we cancel a k with one of the k's at the top, making a 1, and we end up with 1 times 5k, which is 5k. Now this again is a linear equation, so we can solve this by getting the variables on the left, or however you want to do it. I'm going to combine like terms first. On this side we have a 6k, and we can combine positive 5 and negative 3, which is a positive 2. And over here we still have a 5k. Now I'm going to subtract 6k from both sides. Some people get OCD about this. They like the k's on the right, the left all the time. That's not a big deal to me. So we'll do it this way. When we add, we get rid of the 6k on the left side, leaving us 2 equals negative k. And you'll notice this is sometimes what multiple choice answers, when they make these up, they try to distract you a little bit. If we stop here, it looks like our answer is C. But we know we're not finished. We're not solving for negative k. We're solving for k. So we have a negative 1 in front, which means we have to divide both sides by negative 1. So our k is positive, and we have k equals a negative 2. So the real answer is A. Now if you check that in the denominators, you'll notice that it's not going to make a denominator 0, so we can use this answer. Our final answer is k equals negative 2. So I hope you got that or saw your mistakes. If you didn't, let's go to another situation. Number 3. Now on this one, let's see here. Okay, this time we have a little bit different situation because we have a 1. Sometimes it can cause a problem with some people, but we still do the same thing. Our least common multiple here, or least common denominator, pretty obvious this time, it's a squared. So let's go ahead and do this and you'll see what happens. We have a squared plus a minus 20 over a squared times a squared over 1, and then we have an equal sign, 1 over a squared, which we're going to multiply by a squared over 1. But here, I think it's very important to teach you to change these subtractions to adding the opposite. In this case, we want to make it a fraction just so we're multiplying fractions. You'll see what happens here. But you don't have to do that if you don't want, but you'll see later in another problem we're going to do that if you do not change this to plus a negative, you won't distribute the negative in situations where you have a binomial. Okay, let's look at this. Pretty simple. A squareds cancel, making a 1. A squared plus a minus 20 equals. Now we have a squareds canceling. Now a lot of people here, kids here, will put a 0. No, 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 no. 1 is always what we're getting when we cancel. If everything cancels, it's a 1. Now here, negative 1 times a squared is a minus a squared. Now I usually tell my students you got to watch for the squares. If you have an a to the first, like a linear equation like we had on the first two, you solve for a, like you normally would, getting the variable solved for the variable. But in this case, we've got an a squared, which means we have a possibility of having two answers. Now when we simplify, let's see if that a squared is still there, which it's going to be in this case. But since I see a squared, I know I have a quadratic. And to solve a quadratic, you always want to get it equal to 0. And we've been doing that recently, so you should remember this. So I'm going to add an a squared. We want this side to be 0. So I want to get this 0. I'm going to add the opposite to both terms here. But whatever we do to that side, I'm going to add a negative 1 here also, and a positive a squared here. And that's how we get our 2a squared. We got a plus a in the middle, minus 21 equals 0. And we still have a squared term, so we do have a quadratic left here. Now here's what you have to do. I teach the reverse FOIL method, that's what I call it, because of the inside and the outside, or you could say outside, inside, the F-O-I-L, the OI of FOIL. We all know that this first term when we're doing FOIL comes from here, and there'd be this times this. So that's our options for that. There are no other options. But 21 has two sets of factors. 1 times 21, 3 times 7. I always try the 7 and 3, or the most common terms first, common factors first. But that's not always the case. Sometimes you must use 1 and 21. So let's try this. Let's try 3 and 7. Actually, I can see how it works. If you practice this enough, and a lot of my students now, they can do this in their heads. They can see it because they've practiced these two terms. Inside plus the outside is what gives us the middle term. In this case, it's a positive 1. So we have to ask ourselves, and see, this is good exercise for your brain. This is one of the reasons why education has a problem right now with students actually becoming more intelligent and learning. We don't use our brains enough. We use calculators, or we use step algorithms that you don't really have to think, you just memorize steps. This is good for you. It's good for your brain. So here's what we can do. Let's put the 7 here and the 3 here, just to save time. I'll give you the way it's going to work. Now see, when I do this, 7 times a is 7a. Then we've got, 3 times 2a on the outside, which is, 3 times 2a is 6a. Now see, we needed a positive a up here. Positive 1. We can get that if our 7 is positive and our 6 is negative. So, for that to be true, this would have to be positive, this negative. There's no reason for you to ever miss factorization. You can always test them, you can always FOIL them back to make sure they work. And not only do they have to work in the middle, the 7 times the negative 3, positive 7 times negative 3 also gives us the negative 21. So this is, to me, this is the best thinking method that will stick with you. You're gonna forget algorithms. You're gonna forget steps. Understanding will always stick with you. This gives you the understanding of how this works. Now, to solve a quadratic, we take the two parentheses and set them equal to 0 and get our answers. First one is 2a plus 7, subtract 7, divide by 2, and we get a is negative 7 halves. Well, it's pretty obvious our answer up here is B, since that's a multiple choice type of strategy. You look to see if an answer has that singular result, and then you know that if that's the only one that has negative 7 halves, you got the answer. Now, if there's another answer that has a negative 7 halves and a different second answer, you'd have to check the next one, which is easy. We have a minus 3 equals 0. Add 3, we get 3, and now we see it's obviously B. So, what you need to be aware of is when you have a squared, you're going to have to do a quadratic, you're going to have to solve a quadratic equation by setting it equal to 0. Now these problems are set up for you to be able to solve, so every one of them I think are going to be factorable. So you won't have to use a quadratic formula. You can always factor. All right, I want you to try number 4. You need to try the next problem as I change it here. Try number 4, and I'm going to ask you to pause your video right now. Pause your video, try number 4, pick an answer. When you're ready to see how it's worked, start your video again. Okay, now let's see what our least common denominator or least common multiple is this time. Looks like it's going to be 3m squared, isn't it? Okay, pretty obvious. It's similar to the others. So let's do what we've been doing on the others. Multiply every fraction by 3m squared over 1. We have m squared plus 2m minus 15 over 3m squared, and we know what's going to happen there, don't we? That's going to be nice. Times 3m squared over 1. Now here is the important, well, not as important, but keep doing this just so you'll see it later. We haven't run into it yet, but change this to plus a negative 1 over m, and we're going to multiply that by 3m squared over 1. Then we have an equal sign, 1 over 3m. And we want to take that times 3m squared over 1. Okay, now we can simplify. That makes a 1, 3m squared over 3m squared. So now we're left with m squared plus 2m minus 15. Then we have a plus. And you don't have to write the plus if you understand what you're doing here after you simplify, but m cancels one of the m's. That's all that we can do. Negative 1 times 3m is negative 3m equals, here the 3's make a 1. Again, the m cancels with one of the m's here, leaves me an m. Well, we have a squared up there, don't we? That means we need to combine like terms and get this equal to 0. Well, we have a 2m and a negative 3m. That's minus m. Now to get it equal to 0, we need to subtract m. Now we have an m squared minus 2m minus 15 equals 0. This is a nice, easy factorization. The two factors of 15 that can give us a 2 are 5 and 3. And again, if you test the OI, this is negative 5. This is positive 3m. And when we add those, we get the middle term. And when we multiply negative 5 times positive 3, we get the negative 15. So always check those to make sure you get that back, so you make sure you've done it correctly. All right, set m equal to 0, so we have m minus 5 equals 0. That means m is going to equal 5. We have m plus 3 equals 0, which means m is going to equal negative 3. And as we can see, our answer is going to be C. And hope you got that question correct. If you didn't, look it over again and make sure you can see where you made your mistakes. Now we're going to try another situation. Let's go to number 5. Excuse me. And as you can see now, we have a different situation. I'm going to write this up here where you can see it. First thing you need to see is we need to factor the denominators. So let's do this up here. In this denominator, we can take a 3 out. We have binomials this time. See, every situation we had in the first 4 problems turned out to be monomials in the denominator. So now we got a new thing. And the reason this is important is for you to see that now your factors to find your least common denominator or least common multiple, this is a binomial factor, this is a monomial factor. The 4 is not a factor because factors are connected by multiplication. Terms are connected by pluses and minuses. So that means the whole parentheses here is a factor and the 3 is a factor. Now I'm going to leave room here so we can multiply by the least common multiple. Then we have 2 over a minus 4, which it can't be factored. In fact, I tell my students, go ahead and put a parentheses around it. That's one of your factors. Now here you have a minus. You have a minus. We're going to change that to plus the opposite. Now the bottom of this one can't be factored, but now we can see that our factors are clearly, they're easy to see, and we can tell, at least from past experience, we've done this a lot in the last couple of weeks, so you should remember this. You just put the factors that appear up there together and make your least common denominator. So in this case, or least common multiple, you're going to have this, 3a minus 4. Now, if either one of those factors appears more than once in a single fraction, that's how many times you use it. So if let's say it was 3 squared in the first one, then we'd have to use 3 squared. So you have to remember that when you're doing least common multiple. All right, now we're going to multiply each one of these by, well, let's just put parentheses again. 3 parentheses, a minus 4 over 1. And we're going to do that to each one of these. Let's move this one over a little bit farther. So I have a little more room here. We've got a plus, a negative. So here we're going to have 3 parentheses a minus 4 over 1 times that. And here we're going to have 3a minus 4 parentheses all over 1. Now you might want to take a look at that. See if you see everything clearly and how we've done this. We've multiplied everything by the same thing, the least common multiple on both sides. Now this one's nice. What happens here? They all cancel, leaving me 1. Now in this particular set of fractions, only the a minus 4's cancel. So that leaves me 2 times, because these are multiplication, contained by multiplication, 2 times 3 is 6, plus, now here's where this is really important. You'll notice I canceled the 3's, but now I have a negative 1 times a binomial, which means I have to distribute that negative. And see, if we didn't make that plus, or adding the opposite, most of you would not distribute that negative. I've seen it over the years that it happens every time. So this is why this helps you. Just be in the habit of always doing that. So now we have a negative a plus 4 when we distribute. It's amazing how simple the equation becomes after we get rid of our denominators. Happens pretty quickly. Now we add like terms. We have negative a plus 10. Now we're going to subtract 10 from both sides so we can get the a by itself. Solve for a. We have negative 9 equals negative a. And of course we can't stop here. You have to divide by negative 1. And now we see that a equals 9, which is our letter B. All right, pause your video. And I'm going to go to, well, don't pause yet. When I get to number 6 here, and clear this. Now you can pause your video, go ahead and do this one, and see what you get, and we'll see if you get the same answer I do. When you're finished, just start your video up and watch me work the problem. Okay, here we go. Well, now we've got some denominators to factor here, don't we? So we need to take the first one. We can take an x out of those terms. So we're going to have 1 over x parentheses, x minus 6. We're going to leave space so we can multiply by the least common multiple. Here, this one can't be factored. So we have 1 over x. Leave a space. Plus, now we got to factor this one. 1 over, and here we can take out a 3 and an x. So we'll take out 3x and have x minus 6. Now, you'll see again now, look at all your denominators in factored form. We have an x, and we have a 3. So our least common multiple on the outside would be 3x. See, the x only appears once in each fraction, so we use it once. The 3 only appears once, so we use it once. The x minus 6 now is a binomial factor. It only appears once in each fraction. So there's our least common multiple, or if you were going to add fractions, you'd use that as the least common denominator. Now that we're going to multiply everything by that, we have 3x, x minus 6 over 1 times this one. And we see that the x minus 6 parentheses makes a 1. The x's make a 1. So we can cross it out. And now we have 1 times 3, which is 3. All right. Over here, multiply again by the least common multiple. I'm kind of squeezed there. This is 3x, parentheses x minus 6. Now in this case, only the x cancels there. So we're left with 3 times x minus 6 times 1. So this is what we have left up here. 3 times x minus 6. So now we distribute that, and we get 3x minus 18. All right, let's multiply the last one here. This is going to work out nicely. When we multiply by the least common multiple of 3x x minus 6 over 1, well, that cancels it all. Leaves us a plus 1. And we're back to a linear equation. Just go ahead and combine like terms. Negative 18 and 1 is negative 17. We're solving for x, so we're going to add 17. And we end up with this. Divide both sides by 3. And we get x is 20/3. Now, students are calculator happy. They want to always divide. But every math professional, every math teacher, every math book, 9 times out of 10 are going to leave this exactly like this, because it's an improper fraction, but it's the easiest thing to work with. If you have to plug it back in, it's easy to work with. That's what it has to be in most of the time in that form to do that. When you check your denominators, if you put this back in, it doesn't make any of them 0, but you need this form. Also, if you divide, you're going to get a repeating decimal. See, 3 goes into 26 times, 6 2/3, so that leaves a 2, so that's going to be 6.6 repeating. We know that's 666, and then you'd round it, but see, that's not an exact answer, that's an approximation. We want the exact answer. So leave it like this. All right. Let's go on to number 7 and see what happens in this situation. I'm going to work number 7, and then I'm going to have you do number 8. Well, let's factor these so we can get our least common multiple again. Looks like we have, now we don't factor the tops, we need them in simplified form so we can solve the equation. So we have 2n squared minus 2n minus 60. If we factor the denominator, we can take an n out. Now we leave a little space. We have a plus 1 over. Factor this denominator, we're going to have the same thing, aren't we? And then leave a little space and we have an equals. And we can't factor this one. but it's pretty obvious that our least common multiple or denominator is going to be n minus 4. So let's go ahead and do this one. First fraction, we'll multiply by n minus 4 in parentheses over 1. When we do, this cancels and makes a 1. Leaves us 2n squared minus 2n minus 60. Let's do the second fraction. Again, oops, let's just do this. I know I'm going to have to write small here. I didn't give myself a lot of room. But you know this is going to be n and n minus 4 over 1, which is going to cancel again. So I have plus 1 equals. Then we got to do this one on the right side of the equal sign. And we have n's cancel, but we're left with 5 times, and it has to be distributed, n minus 4, which would be 5n minus 20. Now we've cleared the fractions. I see a squared, so that means we have a quadratic. So we're going to have to get this equal to 0 and solve it. Factor it. Let's combine like terms. 2n squared minus 2n minus 59 equals 5n minus 20. Now if we want this equal to 0, we have to subtract 5n and we have to add 20, don't we? Let's see, subtract 5n. So now we have 2n squared minus 7n minus 39. Now the first thing I look at when I look at a excuse me, a quadratic, and I'm going to factor, I try to take out a common term. Sometimes that simplifies it, makes it easier. In this case, there's not a number that will do that. So now we're going to do this. Obviously, and as we said before in FOIL, to get the first term, that's going to be the only possible factorization. Now 39 has 2 sets of factors. 1 and 39, 3 and 13, and most likely it's going to be 3 and 13. Yes. And again, once you learn this OI technique, you'll be able to start looking at these and plugging them in with in your mind. Do it in your mind. Just do it in your brain. It's like math in your brain practice. And I saw right away that if I put my 13 here and my 3 here, I can get a 13n and in the middle, the inside, and I get a 2n times 3, which is 6n on the outside. So my OI can give me a 7, but I need a negative 7. Well, if this is negative, then the higher one has to be negative. If this is positive up here, then the higher one has to be positive. So that means this is negative, or yeah, then this is positive. So since the 6n came from here, and the 13 is negative, some of you probably can look up and see the answers now already, since you're pretty quick with solving these in your head. But we set them equal to 0. Oops, I'm getting a little over our rambunctious here. And then we divide by 2. And if we tested that in the denominators, we'd find that that does not make the denominator 0. In fact, you can look at the factored form and tell us what's going to make it 0. If n is 0, it would make it to 0, wouldn't it? Or if n was 4. So since none of those were our answers, excuse me, we know right away that these are going to be okay. And the second one, n plus 3 equals 0, so n equals negative 3. So our answer is B. All right, now I want you to try number 8 when I bring it up. See if you can do this one. Pause your video right now. See if you can work this one out. And then when you're finished, start your video again and I'll work it for you. Okay, number 8. Now, let's see what we got here. we have r plus 5 over, that's an ugly r. Let's do this. Sorry about that. Getting a little hurry. R plus 5 over r. Can't be factored. Now remember what I told you you should do here. Let's leave us a little more room here. Now, remember what I said. Make this plus the opposite. Now this denominator can be factored. Take an r out, and you get r minus 1, don't you? Yep, leave a little room. And this one is not factorable. We have r over r minus 1. Now, it's pretty obvious, should be to you, that this r is a monomial factor. So our least common multiple has an r. And then this is not the same r here in this parentheses. These r's are part of a binomial. So they're not factors in themselves. They are part of a binomial factor, the whole thing. So here we go. Least common denominator, or least common multiple, is r minus 1. Now we're going to multiply each fraction by r minus 1 over 1. r minus 1 over 1. r minus 1 over 1. All right. Oh. Now in this one, we'll see if you remembered how to do this. If we, excuse me, simplify this, the r cancels with the r, but now we have a binomial times a binomial. Let's do that over here. We have r plus 5 times r minus 1. Well, by now you should be able to FOIL. I'm just going to do it quickly. See, this is r squared, then 5r minus 1r is a plus 4r, isn't it? And then 5 times negative 1 is negative 5. So we have, after all of that, from here, we get r squared plus 4r minus 5. A little more work to that one. Now this one's nice because the r's and the r minus 1's both cancel, leaving me minus 1 equals, and we have r minus 1 and r minus 1, but we do have an r times an r here, which is r squared. Now, well this time don't assume that we have a quadratic yet until you look at it. What's going to happen here is when we subtract r squared, we're not going to have a quadratic anymore. We're going to end up with 4r minus 5 minus 1 equals 0. Now we can solve that as a linear equation. And we have r minus 6 equals 0. If we add 6, we'll get 4r equals 6. R equals, we'll divide by 4 both sides. And of course that reduces to 3/2. Now if you look at your denominators, the only thing that makes the denominator 0, there are two things. If r was 0 or if r was 1. So my answer 3/2 is correct, and the answer we would choose. So there was a situation where you had to FOIL after you simplified, and when you solved, your squared disappeared. Let's go on to number 9. Let's see what happens here. All right. Now, the least common multiple on this one's pretty easy. It's just going to be x plus 1. And you can put that in parentheses. I like to, just because I tell my students to be in a habit of that so they realize this is contained in itself. It's not separate. You can't separate a binomial when you're talking about multiplying and factoring. All right. So the first one is 1. times x plus 1. Then we have a plus. We have x squared minus 2x minus 24 over x plus 1, and we need to multiply it by x plus 1 over 1 equals x minus 8 over x plus 1. So we need to multiply that by x plus 1 over 1. Well, of course, this first one here, we just have 1 times this. There's nothing to cancel with the denominator. So we're left with this. Then we have plus. This is nice. This cancels, leaving a 1 times this. And we have x squared minus 2x minus 24 equals, and again, the x plus 1's cancel here, x minus 8. So it looks like we might have a quadratic here. Yeah, there's only one square term, so it's going to stick around. We need it equal to 0, so let's combine like terms over here. X and a negative 2x is negative x. Positive 1 and a negative 24 is a negative 23. Now we need it equal to 0, so we're going to subtract x and add 8. Put them under like terms, and we have x squared minus 2x minus 15 equals 0. And we're back to that same one we had before, it looks like. We had that earlier. Nice one. Factors easily. And we end up with x minus 5, x plus 3, so we get our negative 5 and plus negative 3 gives us the negative 2 in the middle, times each other gives us the negative 15. Now we can take x minus 5 equals 0, so x equals 5. Now check your denominators. It looks like the only one that we have to deal with is negative 1. Negative 1 would make the denominator 0 up here. But negative 1 wasn't one of our solutions, so we don't have any extraneous solutions on this. X plus 3 equals 0, so x equals negative 3, 5, and negative 3. Okay, go ahead. Well, not yet. When I get a chance here to get this cleared. Now you need to pause. See if you can do number 10 on your own. When you're ready, restart your video and watch my solution. Okay, as we write this, we'll factor it where we can. On this side, we have an x minus 1 over 2x. Leave a little space. Now the tops, remember, we don't factor the tops. We need them in this form so we can simplify them and solve the equation. Over here, 2x comes out. That's going to leave me x plus 8. Yes. We check it works. And then we're going to multiply it by, well, we don't know yet. We haven't talked about that yet. Now remember here, we got a minus. So we need to put add the opposite, negative 1 over x. So, looks like our least common multiple is 2x and x plus 8. Because we have a 2 and an x that are factors right here, times. The x only appears once in each fraction. The 2 only appears at most one time, wherever it is. And the x plus 8 obviously only appears once. So we only use them once. So we're going to multiply this by our 2x, x plus 8 over 1. And it looks like the 2x is the only thing that cancels, so we're going to have to FOIL those, aren't we? We're going to have to FOIL that. So let's do that over here. And I'm going to do that quickly because I know you know how to do these by now. X squared, and it looks like it's a positive 8 and a negative 1. It would be plus 7x and then negative 1 times 8. So that leaves us this. X squared plus 7x minus 8 equals So now we take it times, and I'm going to squeeze it in here. You know what it is in case I get a little sloppy. But we have a 2x, x plus 8 over 1. And the nice thing about this one is it cancels completely. So now we have x squared minus 3x plus 2 for that one. Now over here, when we do this one, you're going to see that the x is the only thing that cancels. And again, it's really good if you did the add the opposite on the -1, so you'll distribute it. So let's do this. -1 times 2 is -2, and then we're going to take that times x plus 8. And that'll give us minus 2x minus 16. Well, I don't know if the teachers ever showed you this, but I don't have a problem with this. If we subtracted x squared from both sides, it's gone. So we can cancel that. Same thing as subtracting. Let's combine like terms on the other side. And we get negative 5x with these. And it looks like a minus 14 when we do the plus 2 and the negative 16. So to get this to work, we can add 5x. That gets the 5x over here. And then we can add 8. Let's see what we get here. So the 8's are gone here, leaving me 12x equals, what do we got here? Looks like a -6. Yes. When you add those. Now, we divide by 12. And we end up with, and that is our answer, C. Again, if you look at your denominators, the only extraneous roots would be 0 here for x. 0 times this would make this 0, and we don't have that as a solution. And -8 would. Since -1/2 is not one of those situations, we can use it as an answer. And that is solving rational equations.